Okay, the focus today, I want to show you how you can use the across syntax. Basically, try to recall what you did back in 1090. How do you do universal quantification? How do you do existential quantification? That's basically what the across is for, and other purposes as well. I'll demonstrate all of them. For you to really do a little bit study beyond this particular demo, I would like you to go to the lectures page, and I already posted 2 slides. I may refer to some of them maybe in the class or in the lab later. But for today, I just want to show you the reference. There is a slide called Eiffel Overview Common Syntax. You may want to go over this very quickly to see all the syntax. Somewhere at the end, we got the across syntax for you. Like a simple example. I'll do a different example today. And then, for those of you who might hit some syntax wall when you're trying to do your lab, the common errors slide here, it can also be useful. It tells you what the common errors are for you to get your code not to compile. Also refer to it. Okay, I'm going to also demonstrate some of them as well today. Okay, that's about a reference you should really look at. Okay, and now let's try to do a little bit demo. Remember Eiffel new? So on your terminal, I would suggest we create a brand new project. Okay, and then we experiment with the syntax. Eiffel new on your terminal, okay, if you do that, it's gonna, sorry. Maybe I forgot to set up on this computer, but I'll go to the website. Sorry, bear with me. Do you remember the website for Eiffel new? Anybody remember what exactly it is? Can I actually find it? Oh, there we go. Okay, go to eecs.yahoo.ca, tell the Eiffel/Eiffel new. Okay, that's a website you should know about for Lab 0. Okay, go there, and then of course you got to log in. Okay. Okay, so now let's create a brand new project. What about test quantifications? Test quantifications. Okay, we're going to try both kinds of quantifications. And then you'll say submit. It's going to show you the zip. Say OK. Go to your desktop, maybe under your EECS3311 workspace, right? OK, go there. OK, it's now saved. Go to terminal. Let's now go to CD, go to your desktop EECS3311 workspace, right? You should have the zip over there, test quantification.zip. Unzip it, test quantification.zip. Okay, so now let's try to compile in eStudio. On your terminal, you may have to type eStudio 1905. Okay, let's now add that projects. Add projects and go to maybe your desktop, EECS3311 workspace, test quantification, and choose the ECF to compile. Okay. And then we'll say open. Okay, let it compile. While it is compiling, I would like to give you a little bit concept over here. Okay. Now let's review very briefly about how you write quantification, like what you did, how you did it in 1090. Basically, you have to know how to write this and how to write this, right? Okay, let's do the simplest example. Let's say we just got integer interval, and then we do collection afterwards. Let's say for every I, okay, which is of type integer, such that, okay, the vertical bar means such that, and you give a range. You can say maybe 1 less than or equal to I, less than or equal to 10, okay? And then it is the case. I square is less than or equal to 100, okay? So now, one thing to say, this one is about the type, and over here is about the range, and over here is about the constraint. Okay, and of course, the syntax will be very similar for they exist as well. And for all means every number that satisfies the constraint, every number that satisfies the range must be satisfying the constraint. Otherwise, it gets false, right? You know that. So now let's see how we can write this in Eiffel. Okay. Let me show you the syntax. What you got to do is you have to, let's go to Eiffel Studio first. Okay, it compiles, and then let's now see what we have. Okay, so we don't need to create any model just yet. Just go to the tests over here and go to test example. Okay, by default, it got some tests for you already. Let's get rid of all of them. Okay, get rid of, let's say, only leave T1 over there. Let's start from T1. Okay, get rid of T0. And for T1, we simply get rid of the local, and then we get everything else out. Okay, and then eliminate everything else. Okay, just make it clean. Okay, we only got T1. And one thing to mention to you, for your lab number 1, you're required to write at least 10 test cases for your heap. That's the just a magic number we gave to you, but you should have more than 10 test cases for your own sake. Okay. And then always make sure when you're writing your test feature, always start with the comments. Always start with that. Okay? And then you have to give the test number T1, followed by a colon, and then give some brief comments over here. So we can say test for all on integer interval. Okay, let's see. So now, there is code completion for writing the across. However, when you're using the code completion, be careful, because usually the one that's generated to you by default may not be the one you want. Okay? So now, if you simply type across, okay, and say enter. Okay, notice two things over here. After you type code completion, one of them is S, one of them is loop. Okay? So syntactically speaking, you basically got many options over here. Let me just tell you all the possibilities, right? You want to know which one to use. So now, if you got across something, okay? And now, over here, it could be S, or it could be is, either one. And they make a difference. S, and then you got another thing over here. It's actually for a local variable. I'll just put here over here, some new local variable. And over here across, this will be some collection. Okay, so this can be either S or is, either one, but not both. Okay, and then start with across. After this, you got three options, right? It can either be a loop, okay, in which case it's like a normal loop. It's similar to the for each loop you do in Java. Let's say for each element in the array list, I would like to print it out, right? Like a for each loop in Java. It's very similar. It can be loop, or it could be or, which correspond to for all, okay? Or it could be sum, in which case it corresponds to there exists, okay? And then you put something over here. So this is the body of the across. But it depends on whether you choose loop or all or sum. The body might be expected a little bit differently. I'll demonstrate to you. And then after this, it's going to be just end. Okay, let me highlight the keyword you should know. Across, either S or is, either one. And then followed by, ended by end, either loop or all or sum. Okay, that's a complete syntax. When you generate a code by default, it's going to give you the loop option. The loop option is only useful when you try to do implementation, but not when you write contracts. Okay, let me just say one more thing. The number one concept you need to have is for any feature you're trying to implement. Let's say I have a feature F with some input over here. Okay, and then first of all, what would be the order of the keywords? You have to, of course, you put some comments over here for your feature, right? So over here you can say comments for F. Okay, and then after this, you may have a precondition. Okay, I'll talk about what it should be there in just a moment. And then followed by if you want some local variable. And then after the local, you can have do. And then after that, you have ensure. And after that, you have end. Okay, that's the most keywords you can use for your feature. Local is optional. If you find that you can get away around without using local variable, that's okay. But a very common mistake, very common, is simply to swap them. You have local here and require here. This is wrong. This will give you a syntax error. I see many students actually doing this in the lab test, and they didn't know why it didn't compile. Let me explain why it would be the case, right? Thinking this way. Let me just undo. Think about this part over here, local together with the do is your implementation. And require and ensure. So these two are the contracts or specification. So if you actually move the local before the require, you kind of mix them together. So that's not good. That's how you remember it. Okay? Questions so far? Okay. So that's about the syntax. But and then about what you can put inside each clause. Okay? Let's see this. So inside require and also inside ensure. So the green ones. Okay? Always remember you can only put Boolean expressions. Boolean expressions only. In other words, a very common mistake, I saw many of you doing that already. You cannot put just a from until loop over there. You cannot. Because from until loop is not a Boolean expression. It's simply like an instruction to do something. It does not return a Boolean. Okay? I'm going to demonstrate that in the Eiffel Studio. And then after this, let's say we got pink. And this is the implementation. And in here, you can put any kind of instructions. For example, assignments, call it equal, right? That's the assignments. Or you can put a if then else, or you can put a from until loop. Okay, so these are the typical ones you can put. But never put any of these in the contracts. Yes? Yes, you may. As long as the feature returns Boolean. Yes, the question was, can you make a feature call in the require or ensure? The answer is yes. You will actually see that in the lab 1. For example, one of the invariants is about the maximum heap property. We call the feature is heap, right? That one calls the feature. Right? Okay, that's about general guidance. Make sure you understand the structure over here. That'll save you lots of time just to get your project compiled. Okay, so let's now demonstrate some simple example. Okay, so now how do we do the thing? Let me show you the easiest one. So now we are now in the context of kind of implementation, right? Actually, in the implementation, depends on what you really want to do. Let's say I want to do some quantification. I want to know whether it's true or false. Let's say I simply just want to translate this particular predicates into Eiffel. How do I do that? I want to know if all the numbers between 1 and 10, if their square is less than or equal to 100. Let's try. Okay? So what I will do is, let me write it out. I'm going to do a test. So now I want you to do, first of all, I know that the result, which is Boolean, the test, I want to assign that to some other Boolean. Result is assigned to something, right? Let me fix the indentation here. Okay? So now, tell me something. Do you think if I just write a loop over here, would it work? Would it compile?
If it's all or some.
Yeah, it should be all or some. That's the issue. If you use the loop over here, the loop itself does not return anything back to you. It simply does something. So that's a very important thing to note. So what I should do is, I know that the default loop is not good for me, so I'll simply just say all. Let's say all correspond to for all over here. And then, now here's the thing. What do I want to cross over? According to this particular expression here, I basically want to cross the range between 1 and 10. Starting from 1, ending with 10. There's a syntax for that. I'll show you. How do I create an integer interval as a collection? Start with the lower bound, vertical bar, dot, dot, vertical bar, and then 10. So this guy over here is an integer interval that will be treated as a collection that you can iterate through. Okay? And now here comes the tricky part. Okay? The default over here is S. That's completely legitimate. I would say I will do this second. The easiest one for you to do is to remember, change S to is. This is actually a new addition just to 1905. So I'm showing you. They might change the code completion later, but for now. The easiest way is to change S to is. Okay? And then I simply want to say every number I'm trying to iterate through this interval, I just call it I. Okay? So now take a guess. What should be the type for I? Integer, very good. That's very straightforward. However, if you use s, it would be different. It's a little bit confusing for the s, but I'll explain that anyway, so just in case. Okay? So I will be there, and then I will simply do over here, let's say I times I, okay, less than or equal to 100. Compile. And just to really convince you, what if I simply do loop? You will fail to compile. Okay? You can look at the error message yourself. Okay, so now change back to all. So now would you expect the result to be green bar or red bar? Should be green, right? Everything is less than or equal to 100, right? If I simply try that, run workbench system. Okay, green. What if I try this? Green or red? Red, right? What would be the counter example? When I is 10, 100 less than 100 is false, right? So that means not all of them, right? Let's give a try. If I try that, I should get a failure, right? You can play with this. I'll mention one more thing. Okay, fail. Very good. So now let me go back here. Okay, so now on the other hand, so now you can do a little bit manipulation here. I know that it's going to be false. I can say result is not the case for all. You see what I'm doing here? The whole thing is Boolean. I put a parenthesis around and say not. This simply corresponds to not the case for all. That's basically what I'm doing mathematically. Okay? Everything corresponds quite nicely to math. Okay, let me go back here. I know that, so now it should be okay because this guy here is going to be false. Not false will be true. Okay? Let's double check and then I'll show you some. Okay, workbench system. Good. Let's do one more. Okay, so now I can say check result n. Okay, after this, I'm going to do another one. Okay. So now I'm going to just use another one. What if I say, rather than all, I say some? True. Give me one witness. One. Yeah, exactly. Yeah. Okay, you can see the thing, right? So some simply correspond to the existential quantification operator. Okay. Okay, so now let's verify that, and then I'll talk about S. Okay, good. So now about the S syntax. Okay. Okay, let me see if I can actually do this. I'm going to try this. Okay, what we got over here, I'll choose one of them. Okay. Yeah, give me just one moment. I'll set it up. Give me one moment. Good. That does work. Good. Question first. I'll talk about nested. Remind me if I forgot. I'll talk about nested at the end. Yeah. Okay, so now this is working. Okay. Now I want you to see this. So we change the default S to is, right? What if I change that to S? Right? That's a question. So now I simply, let's say I cross it out. I say S, I. So now, do you want to take a guess what the type of I is? Well, it's integer, right? So there's no address. Okay? Okay, I can tell you that it's no longer, I is not integer anymore. Not anymore. I over here is not an integer. If you change from S to if you change from is to S, not an integer, rather a cursor pointing to an integer. So this is the old style of writing across before 1905. That's why the code generation still gives you this old version. You can feel free to use it, but you gotta be very careful. Okay? So now, how can we change everything else accordingly? If I itself is only just a cursor, which means you can think about I is basically a cursor pointing to the integer interval, let's say 1 up to 10. The first iteration is going to point to 1, second iteration point to 2, third iteration point to 3 indirectly. Now, how can we actually get it, right? Okay, you got to say something, okay? The way to do it is by saying rather than I dot item, then you're done. Okay, so I would say, I would suggest you always use is. That can avoid confusion. If you want to use as, that's okay, no problem. Okay, but you will see that the contrast I wrote for Lab 1 and also for the binary search example yesterday, I used is, just much easier. But I'm going to put it on the code just for your information. Okay, I'll just do one of them. Okay, so now I can say check result n. Okay, so now let's do another one. So now let's see this. Okay, that's the one we had. Now I'm going to change from is to s. Okay, now let's illustrate. It's really going to give you compile time error. Okay, so invalid operator expression. If you try to just read it a little bit more detail, we'll try to do it together. Basically, you can see that what we're trying to do over here, we try to use I with the less than sign. However, I itself is not integer. It's a cursor to integer. That is why it would say indexable, basically just the cursor. It's saying there's no less than defined for the indexable cursor. Okay, that's why. So how do we fix it? You got to say I.item. I.item. Okay, let me make a comment over here very quickly. I is cursor to integer. And on the other hand, over here, if you use is, I is integer. Okay, now also fine. Any questions so far about interval? Interval is already very powerful. You can already go across the array using the index. I'll give you one example. Okay. Let's say in the same, let's use a different test. Let's say T2. T2, Boolean, okay, and then we'll say do, and always put the comments. Okay, and then make sure we have T2. Okay, let's say test array using interval. Okay, and make sure always when you add your test feature, make sure you add it here as well, right? Remember the tutorial told you, okay? Add Boolean case, agent T2, okay? And now, let's see this. Let's say we create another integer array, maybe a string array. Let's say names, array of string. Okay, and then let's say names is simply equal to Alan. Okay, let me just type. And we have Mark, and we have Tom. Okay, let me make sure. General advice, you should really try to recompile your system every 2 or 3 changes. The reason is, as soon as your code stops to compile, your best resolution is undo to the last point that you compile. That's the strategy. Rather than saying you only compile every 1 hour, you don't want to redo all your work, right? Undo all your work for the past 1 hour. Okay, after this, let's see this. Now, how can we check to see if there, how can we use across to check, let's say Mark exists in the array. How do we do that? Use across. Should we use across sum or across all or across loop? Sum, right? You want a Boolean value, so either all or sum, okay? So now we'll simply say result is assigned to, okay, across, and now I would say change this to is right away before you forget. And then we know that we gotta say sum. Okay, so now for this particular example, you have 2 options. You can either use index or you can use the contents directly. I'll show you both. However, I would say using the index is a more general solution. Sometimes, for example, if you want to check duplicates, you may actually want to use indices. Okay, so let's use the index first. So now, how do we say all the valid indices for the array? Any suggestion?
A dot lower.
A dot lower until A dot upper. That's one way, okay? You can either say A dot lower. By the way, lower is a feature for the minimum index, okay?
It's names. Sorry.
Oh, thank you. Yeah, names. Very good. Names dot lower and all the way until names dot upper. That's one way. I'll give you another alternative. Since we can assume the array indices start with 1, you can say 1 until, let's say, names dot counts. That also work, okay? Now let's say every index is I. Another mistake you want to be careful. When you choose the local variable, like a dummy variable for the across, make sure the name does not clash with any of the attributes or parameters or the local variable. Okay, make sure. So convention you may follow is like this. Rather than calling I is a very common name for loop counter. So you can say L standing for local underscore I. Okay, it's just a suggestion. Okay, okay, L underscore I, and now I can say names at position Li. Okay, and then I can say using tilde like an equals method in Java, right? And then we can say mark exists. Okay, now we should really get true. Okay, unknown identifier, oh, Li, sorry, not L1. Okay, so now this is done. Do you think the test will pass? Okay, good, let's verify, please. Okay, very good, we got 2 tests already. Let me do one more and then we'll take some questions. And then we'll move on to a little bit more complicated things. Okay, after this, let's do one more. What if I don't want to use any index? Maybe I don't have to for this particular example. What I can do is I can simply say result is assigned to, again, I'm going to say across and change that to is right away. And then I would say just names. Okay, we'll talk about a design pattern called iterative pattern. Maybe next week, maybe next Thursday most likely. We'll talk about it. But now you can keep this in mind. Every collection class in Eiffel is iterable, like array, linked list, array list, hash table, etc. You can always use across on them. Okay, so now if I say names is, let's say L local name. Take a guess, what should be the type for L name? String? How did you figure? You're taking the value for the member, right? Basically, you can see the collection is names. So it's going to be array of string. Every member is a string. So when you use the is version for the across, so L name is going to be of type string. Okay, I'll make a note for you. L name is of the member type of names, which is string. So now I can simply say, rather than loop, I can say sum. And then I can say names. Over here, L name is mark. Okay, so this also works. Let me see what I have over here. Oh, you're right. Sorry. Yeah, I just confused myself. If you make this mistake, yes. The reason is L name is a string. I was thinking about using index. Absolutely. Thank you. All right. So this makes sense, right? You really want to compare the 2 versions. For one, you simply use the valid index. The other one, use the member. The number one, the former is more general than the latter. Okay. Question. Yes, you talk about the old keyword. I would say save the old keyword a little bit. We're going to talk about it tomorrow in the class. That one will take 1 hour to discuss. Okay, let's leave that. Yeah. Well, I'm exaggerating it. Maybe 20 minutes. Okay, very good. Everything compiled, and then we're going to run it. Okay, that's good. So far, any question before I talk about nested? We're good? Okay. Let me talk about nested loop. Remind me if I forget. I'm going to talk about nested to give you some idea. You might need that for the duplicates. Okay. And then after that, I will talk about how you can write loops in Eiffel, and that'll be it. Okay? Just remind me if I forget. Okay, so now let's see how we can use nested. For nested, I don't need to type anything. I just want to give you some idea. How do you write nested? The idea is very simple. Since now you're in the 3rd year, right? Basically, every programming construct itself is recursive, meaning that, for example, if I have the across syntax, if I say across, something is, underscore means keywords, is something, let's say, if I say all, end. Okay, that's about the syntax. And also, you have something over here, right? That's kind of general structure. And now remember, what should be the type for this particular thing here? Boolean. Boolean type, right? Boolean expression means you can put anything that's Boolean. For example, you might put, for example, 3 greater than or equal to 2. That's a Boolean. You might simply put true. Okay, that's another option. Or you can put another across. You see what I mean? So now maybe I'm going to wipe out these just to clean it. So now what you can do is you can just put another across. Is something, and then maybe I will have some this time. And then this is another Boolean and end. Can you see the nested structure here? It makes sense, right? And nothing will stop you from writing another across if necessary. Okay? Hopefully that gives you another hints, enough hints for the lab. Okay? Okay, now I'm going to talk about loops. Okay? Before I go back to Eiffel Studio, I want to explain to you the syntax quickly. Okay? Let's start with the more general loop. Okay? If you need a little bit comparison, this might be the best way to think about it. You know, let me just give you one example. Let's say integer, let's say Java while loop. Okay? You would say integer I is simply 1. You would say while okay, actually, you know what? Let me make it a little bit more interesting. 0. So while I is less than, let's say A is an array, let's say A.length. It is the case. And then we're going to say, let's say we're simply just going to see Boolean result, let's say is simply equal to true. Okay? And then we want to know if all the numbers in the array is positive. Okay? So we simply say 8 at position I is strictly larger than 0. Okay? And then, of course, we'll say result is result and this. Okay? Of course, I is assigned to I plus 1. Okay, that's a loop. You know how to write it, right? Let's see how we can translate this in a general way to Eiffel. Okay? The most important thing is to understand the condition over here. So if you look at that over here, I call this the stay condition. Stay. As long as this condition is true, we're going to stay in the loop. In Eiffel, you go the opposite way. It's called exit condition. As soon as something is true, that means it's time to exit. Okay? So now let's have a look. How can we write it? Okay? Let me just write out the general structure. It's going to be from, until, loop, end. And remember, never ever try to put this under the require, ensure, or invariance, right? It doesn't return Boolean. So now how can we do that? Okay? So now this part here is for initialization. So that means you can simply copy these two. Okay? So now, okay, that's the initialization. Okay? I'm going to code it up, okay, for you. And then, what about the until over here? Any suggestion? until, well, think about the logical negation, right? So what will be the logical negation for less than? Greater than or equal to, right? Good. So what you're going to do is until I is greater than or equal to a dot length. Something like that, okay? And then the rest, you can simply move them here. That's it. So the only thing you got to pay attention to is the exit condition. If you put the state condition over there, too bad, right? You're going to run into trouble, okay? So now let's try it, okay? Let's code it up. So now let's go back there, okay? And let's try for test example. Okay, let's say T3. I'm going to just be a little bit lazy here. Let me copy and paste. Okay, so we're going to have, let's say, numbers, array of integer. And then we're going to have T3 here, and then T3 test loops. Let's say numbers over here, let's say make it easy. Let's say 1, 3, minus 2, and 4, okay? And now, one thing to note, if I simply, okay, I'll mention this at the end. Okay, what I will do is, first of all, let's type the keyword from. As soon as you do that, it gives you this whole structure over here, right? And then we're going to see what's the initialization. Initialization should be, first of all, the result. Let's say we just use the result over here, right? That should be initialized to be true. Okay, true is a keyword. And then we're going to say we need a loop counter. So now let me declare loop counter I, integer. That is why I said before, when you do the across, you don't want to use I, because it most likely will clash later, right? Okay, after this, I would say I is assigned to, now you cannot say 0. Be careful. You either say 1, or you want to say names, numbers that are lower, right? Let's say lower. Lower is actually quite nice to use. Okay, you can say numbers that are lower over here. Now until, as we agree, it's going to be I larger than or equal to a dot length, maybe larger than or equal to. Now, what should that be? Well, since we start with the lower, right? Okay, one thing to note, okay, you will work out the logic. Basically, think about if the array indices is simply, let's say, make it simple, 1, 2, 3, and 4. We want to start with 1. And now we want to say as soon as the counter is strictly larger than the upper, we should exit, right? So you can say strictly larger than upper. Or you can say strictly larger than the size of the array, because the array indices start with 1 in this case. Okay, either way. Okay, just to explain that to you. Okay, so now I can say until larger than, strictly larger than, numbers dot upper. And always remember, put this. A very common mistake. So if your summation have an infinite loop like this, too bad. Okay. Question. Let me finish this and then I'll take a question. Yeah. So after this, I'm going to say result, which is Boolean, is going to be result. And now we need a conjunction operator. In Eiffel, simply just AND. Okay. You will see the syntax guide that I just referred to. And then I can say AND. I'm going to say over here, numbers at position I, strictly larger than 0. Okay, everything compile. Okay, you can see the whole thing over here stands by itself. It is not assigned to anything else. What I mean by this is, let me try the following. If I simply say result, which is Boolean, is assigned to the whole loop, do you think that might be okay? No. Again, the idea is the loop itself does not return anything. So it only try to do something silently. Okay. If you try that, it's going to give you basically error. Okay. It simply say, okay, you can read the error. Okay. Okay. So these are all common mistakes. Hopefully, don't make them. Okay. So now, are you convinced that we might get true after that? Or false? Well, we're checking to see if all the numbers are strictly larger than 0, right? There's at least 1 over there. So, no. It will be false. So now, result is false. In that case, what we can do is we can say, well, since it's a test, we got to make sure the eventual result is simply, true. Let me do a little bit of trick. Okay, that should pass. And before I do that, I should really add it. Add Boolean case agent T3. Okay, everything passed. Okay, question.
Yes. Can you go back to the?
Yes.
Sorry. So in the until.
Yeah, for the until, yeah.
Why is it upper? Why is it not count?
Oh, actually, you know what? This case is interesting. Let me go back here. Let's say this is the array we are talking about. Lower is 1, and the upper is 4.
So lower and upper are the indices.
Indices, yes. So lower is the smallest valid index, and upper is the largest valid index. And because the indices start with 1, so upper will just be equal to the count. Agree? Okay, let me write it down before I forget. So if you go back to the code, I can say over here, since indices start with 1, numbers dot upper is simply just equal to numbers dot count. Okay, but I would say usually if I didn't tell you, you can assume the indices start with 1. If I tell you it start with 0, I'll make sure I'll emphasize that to make it clear. Okay? Yes, question. Oh yeah, absolutely. So what you're suggesting is lit. Very good. Okay, very good. So I'm not sure, did you take 1022 or 2030 with me? Oh, maybe, okay, that's good. Basically, what your colleague just suggested, can we try to do a little bit better performance-wise? Asymptotically, it will still be big over n, but at least we can try to exit earlier. We want to say as soon as we find out the result simply just becomes false, can we just exit from the loop? Is it possible? Yes, we can play with the exit condition. Okay, so now until, basically, think about the logic over here. Result is the Boolean. I can say as soon as the result is actually becomes false, right? I can say not the result. Either that or that. Okay, think about the logic. Okay, that one I wouldn't go too much in detail. If you really got trouble figuring this out, talk to me. Okay, what I'm trying to say over here is for the exit condition, it's just a Boolean expression. Feel free to use any logical operator. Conjunction, disjunction, implication, negation, feel free. For this one here, it's going to work. Okay, so now I'm going to say exit when either result becomes false or when I becomes too large. Okay, and now we can improve this a little bit. We don't need this anymore. We can simply say result is simply assigned to numbers at position I larger than 0, right? As soon as it becomes false, right? That's a nice review for logic. Compile, and then we can say run. Everything still pass. Okay, I think maybe since time's a little, I thought I would just take 20 minutes. Apparently I talked too long. I will leave the last thing about how you can use the across loop. I'll leave that maybe a little bit later. You don't need that. You can just use the front until. Hopefully that's clear enough. Any questions before I end the recording? Any questions? Okay, I believe you got just enough to finish your lab 1, except for the old keyword, which I will cover tomorrow in the lecture. Okay, I'm going to post the recording in just a moment. I'll let you know when it's done.